Hi, algebra, we're going to go over the chapter 4 closure problems. Okay, so starting with 116, solve the system of equations at the right. So first we're going to solve it algebraically. So let's do this. So when I look at this right here, I see a y equals, and that makes me want to use substitution. I know y equals 3x plus 2. So here where I see a y, I'm going to substitute in 3x plus 2. So I have 6x minus 2 times 3x plus 2 equals 8. This, just the 2, the minus 2 is distributed to both of these. You don't add these first and then distribute. It's 6 minus 2 times this, and order of operations says you multiply before you add or subtract. So it would be 6x minus 4, right? Negative 2 times 3x is negative 6x, negative 2 times 2 is negative 4, equals 8. 6x minus 6x is 0x, that's gone. So I'm left with negative 4 equals 8. When the variables cancel and I'm left with a false equation, that means no solutions. And then in part B, you're asked to graph the equations and kind of verify that it's no solutions by looking at the graph. So we know from before, when we have no solutions, that means the lines don't intersect. It means we have parallel lines. So we should expect lines that are parallel right here. This equation is already in slope-intercept form. Right? Remember, B is the y-intercept. That's where the graph hits the y-axis. So at 2, in the spot of my m, I have 3. But for slope, I want to think of it as a change in y over a change in x. So I'm going to put this over 1 to turn it into a fraction. So my y-intercept is 2. So I'm going to start at 2 on my y-axis, and my slope is 3. So that means I make a slope triangle where the change in y is 3 and the change in x is 1. Okay, I'm going to do a few more where I go up 3 over 1, and then I could also go down 3 back 1. 3 back 1. It is hard to draw an accurate line on here. All right, so let's see here if I can get a line. Start here and see if I can get this through here. It's actually pretty decent. Okay, now this one is not in slope-intercept form. So remember last chapter we talked about solving an equation for a variable. Okay, so we're going to do that here. I want to solve for y to get it in slope-intercept form. So I would first subtract the 6x. I would bring this down as a negative 2y equals, and I'm going to put my 6x, my minus 6x first because I want it in slope-intercept form, and then plus 8. And then to get the y by itself, I would divide both sides by negative 2. So I'd have y equals negative 6x divided by negative 2 and 8 divided by negative 2. So then that would give me y equals negative 6 divided by negative 2. So that would be y equals 3x, and then this would be minus 4. So for this one, my slope is 3 again, which makes sense because the lines are parallel, so they should be increasing at the same rate. And my y-intercept is negative 4. So I'm going to start at negative 4 on my y-axis, and I'm going to go again 1, 2, 3, up 3 over 1. So the change in y over the change in x, and I'm going to do a bunch of those so that my line is pretty accurate. And then let's draw my line. Okay, so you can see on the graph now that lines are never going to intersect. So it's no solution. So how does the graph of the system explain what happened with the equation, right? Because there's no point of intersection, then there's no solution. Okay, so let's write that down. So no intersection means no solution. All right, so let's look at 117. So same idea, we're going to solve the system, and then we're going to graph the equations, and again, explain how graphing explains what we got for our answer. This looks like a good substitution candidate again. I have y equals 6x minus 3. So right here, in place of the y, I'm going to substitute in 6x minus 3. Again, I'm going to distribute just the minus 3 to both of these. I'm going to keep this 18x. So I'll have 18x minus 18x. A negative 3 times a minus 3 times a minus 3 is a plus 9. So again, this is 0. So now I'm left with 9 equals 9. When the variables cancel and you have a true statement left over, that means infinitely many solutions. So not all real numbers, because it's not any number, it's a lot of numbers, but we don't know what those numbers all are. It's infinitely many solutions. Okay, so now we want to graph these equations again. And we had talked about before, if it's infinitely many solutions, you should get the same line right on top of each other. So this one is already in slope-intercept form. So m is 6, and I'm going to think of it as 6 over 1, so I can see a change in y over a change in x. My y-intercept is -3, so that means my graph starts at -3, and then I go up 1, 2, 3, 4, 5, 6, and over 1. Let's see if I can get another one. 1, 2, 3, 6, and over 1. And then here I'm going to go down 6, 1, 2, 3, 4, 5, 6, and back 1. And let's draw a line through here. Okay, there's my first one. I should expect that when I rewrite this one, that it should equal the same thing as this one. So if they coincide, if they're the same line, you should have the same equation when I rewrite it. So I'd have -3y, so I'd start by subtracting the 18x. And then I would divide both sides by -3. So I would have y equals, I have to do -18x divided by -3, which is 6x. And I have to do 9 over -3, which is -3. So it is the same equation. So when I go to graph it, it's just literally the same. When I go to graph this line right on top of it, it's the same line right on top of itself. It looks like it's just one line, but it's the same line. It's hitting at every single point. So how is this? Does this graph explain what happened with the equations? They're the same line and hit at infinitely many points. Wow, my handwriting is really messy on this. Okay, let's take a look at 118. So we're given all of these systems and asked to solve using any method. So we've talked about when we solve systems, if you already have something solved for y or x, then substitution might work, or equal values. If you have the x's and the y's lined up where you can easily add and cancel, then you might want to use elimination. Looking at this, they're both y equals. Y equals this, y equals this. Well, if these both equal y, that means these expressions have to equal each other. That's our equal values method. Okay, so then we're going to solve this equation and get our x. So I think I would add 4x first, get all the x's to the left here. So I would have 7x plus 7 equals 21. And then I'm going to subtract the 7. So 7x is 14. And then when I divide both sides by 7, I get that x is 2. I also want to know what y is. So I'm going to take this x equals 2, and I'm going to substitute this into either of these two equations for x to get my y, and it makes no difference. Okay, so I could do y equals 3 times 2 plus 7. So then y is 13. If I did it here, if I did -4 times 2 plus 21, that would be -8 plus 21, which is also 13. So I have my x, and now here I have my y. And so when I write my answer, I write it as an ordered pair, 2, 13. Remember, you can always check your answers by substituting them in. So here, if I were to do 13 for y, and then if I put 2 for x, right, that's 6 plus 7, that's 13. And then here, if I did 13, does that equal -4 times 2 plus 21? Yep, 13 equals 13. So you can always check your solution. So you know something's a solution if when you plug it into both equations, it makes them both true. Now for B, I think for this one, because I have the x's lined up and then the y's lined up and then the numbers and the equal signs lined up, I would use elimination. And I'm noticing here that the y's are opposite. So I can just go ahead and add. So this is 3x. And then I'm going to think of this as plus a -1x. So that's 2x. The y is equal 0. And then 17 plus -7 is 10. And then I can go ahead and divide by 2 and get x is 5. And once I know x is 5, I'm going to put that value of x into either of these equations and solve to get my y. And it doesn't matter which. I think the bottom one looks easier. So this would be -5 plus y equals -7. And then if I add 5, I get that y is -2. So my solution is 5, -2. Again, you can check and see if you're right. If up here you do 3 times 5, because 5 is x, minus a -2 is that 17. So minus a negative is positive, that's 15 plus 2, that's 17. If here you do the opposite of 5 plus -2, which is my y, does that equal -7? Yes, it does. So I know that's correct. And then for this last one, let's see what we have here. Well, I see this is already x equals. The x's and the y's aren't, like, the equal signs are not lined up for elimination. But I know that x is equal to 3y minus 5. So here, in place of this x, I'm going to substitute in 3y minus 5. And then solve this equation. So here I would have 6y minus 10 plus 12y equals -4. And so then when I add, these are on the same side, when I add these, I get 18y minus 10 equals -4. And I'm going to add this 10 and get that 18y is 6. And then to get the y by itself, I'm going to divide both sides by 18. And everybody's going to freak out because you get this fraction. 6 goes into 6 once, 6 goes into 18 3 times. So your y value is 1/3. All right, don't freak out. If it's a fraction, what you always can do is just plug it back in. Sometimes answers are fractions, just roll with it. So to get my x, I'm going to substitute the y in here. 3 times 1/3 minus 5. 3 times 1/3, that's just 1. So 1 minus 5, so x is -4. So -4, 1/3. All right, and then if you weren't sure about your answer, always you can go back and say, okay, is -4 equal to 3 times -1/3, or not -1/3, 3 times 1/3 minus 5? Well, that's 1 minus 5 is -4. Here, if I do 2 times 4, or 2 times -4, that's 8, plus 12 times 1/3, well, that's 4. Does that equal -4? Yep, it does. Okay, so again, you can always check your answers to make sure you're correct. All right, so now for number 119, or 4-119. Bob climbed down a ladder from his roof while Roy climbed up another ladder next to him. Each ladder had 30 rungs. Their friend Jill recorded the following information. Hey, Bob went down 2 rungs every second. Roy went up 2 rungs every second. At some point, Bob and Roy are at the same height. And then we want to write an equation, or we want to figure out which rung were they on when they were the same. So to me, this lends itself to being written as a system of equations. So, and if it helps you to visualize it, you could make a table for each of them. You have Bob and you have Roy. We know the ladder has 30 rungs in it, and Bob is climbing down from the top of the roof, and Roy is climbing up. So then Bob, after 0 seconds, so X is like your time, the rung he's on, right, that's like your Y, is 30. Then after 1 second, he goes down 2, and after 2, he goes down, he keeps going down 2. Okay, that might help you to see, okay, well, what is my equation if he starts at 30 and goes down 2 rungs every second? So Y equals 30 minus 2x, or -2x plus 30. And then Roy is on the ground. So again, X is time and Y is what rung he's on. So he starts on the ground, and then for every second, he goes up 1. So he's Y equals, it's going up 1 every time. So 1x plus 0, or just Y equals 1x. And I want to know when they're equal. Well, if they both equal Y, this is equal values method, I can set these expressions equal to each other and solve for X. So X will give me the time at which they're at the same height. So all 30 equals 3x. And then when I divide by 3, I get X is 10. So after 10 seconds, they're the same height. And to figure out what that height is, I can put this 10 into either equation. So I could put it here or I could put it here. Well, I mean, this is just x equals y, right? They're at the same height and the height, or rung, the same height, which is rung 10. All right, so now in 120, we are solving equations. Just solving good old-fashioned equations here. All right, so this one, variables on the same side, I'm going to subtract 4x. So I have 2x minus 11 equals 12. I'm going to add 11, so I have 2x equals 23. And then I'm going to divide by 2, so x is 11.5 or 11.5. Again, you can plug those x's in, it should make the left side equal the right side. Okay, this one I'm going to distribute first. So I'm going to have 6x minus 10 equals 6x minus 4. And I notice I have a 6x on both sides, and on this side I'm subtracting 10, but on this side I'm subtracting 4. It doesn't make sense. Let's see if I subtract this 6x from both sides, I'm left with negative 10 equals negative 4, and that's not true. Remember, the variables cancel, you're left with a false statement, no solutions. Just like when we're solving a system, no solutions. All right, this next one, I get to use a box from last chapter. So I'm going to multiply this out, making a box. Okay, so here's my x minus 3, here's my x plus 4. This would be x squared minus 3x. This would be 4x and minus 12. So I would have x squared plus, this would make 1x minus 12 equals x squared plus 4. I notice I have an x squared on both sides, so I can just subtract that off. I'm left with x minus 12 equals 4 because these are 0 pairs. I'm going to add this 12, get x is 16. All right, this one is a fraction equal to a fraction, and you did learn back, I think in middle school, about solving these proportions where you can multiply the diagonals, like multiply this by this. You can also do is you can multiply this side by 10 and this side by 10 to get rid of the fraction here. So I have 7, and here I could have 10x over 25, and then multiply by 25 over 10, and 25 over 10. And then when you so this just over here leaves you with x, and so you have 7 times 25, right? 7 times 25 over 10, which is going to end up being 17.5. And the other way that you may have learned about before is that you multiply the diagonals together. So you multiply 10 times x together, so that's 10x equals, then you multiply the other diagonal together, so 25 times 7. So then you have 175 equals 10x, so 7 times 25, and then you end up dividing by 10. So you get the same thing. You still get 17.5. It's just another way to solve that system. Or not system, but equation. All right, looking at E and F, I see fraction fund. I don't like those fractions. So what I'm going to do is I'm going to use this strategy where I multiply through the entire equation by the common denominator. So what's the number that 3 and 4 divide into, which would be 12. So I'm going to multiply everything by a 12 to get rid of the fractions. So 12 times 2/3 x. So that if I go across the top, that's 24 over 3x, so that's 8x. Plus 12 times 3 is 36. Equals, hang on one second. All right, sorry, somebody came in. All right, so back to this. All right, so now I have 12 times 1/4 x. So 12 times 1, so that's 12 over 4x, which is 3x, minus 12 times 7 is 84. And then once we've done that, we can go ahead and solve for x. So we're going to, let's see, I think I'm going to move this over here. 5x plus 36 equals negative 84. I'm going to subtract 36. So I have 5x equals negative 120. I'm going to divide both sides by 5. So x is negative 24. All right, this one I see another fraction. I mean, I could add those, but I just, fraction. I'm just going to multiply through by 3, right? and get rid of that fraction. So 3 times x is 3x. Plus if I do 3 times x over, or I'm sorry, yeah, 3 times x over 3, it's just 1x equals 3 times 4, which is 12. So then I have 4x equals 12. And then when I divide both sides by 4, I get x is 3. What's next? Solve the equations in parts A and B for y, then state the slope and the y-intercept of each equation in part C. Okay, so we had to do this when we were doing those first couple of problems when we wanted to get them in a graphing form. So I would first add the 6x. I have negative 2y equals 6x plus 8. I'm going to put the 6x first because I want to have in slope-intercept form, and then I'm going to divide both sides by negative 2. I have to divide the 6x by negative 2 and the 8 by negative 2. So then I have y equals negative 3x minus 4. When I compare this to slope-intercept form, the negative 3 is in the spot of the slope, not 3x or negative 3x, just the negative 3, and the negative 4 is in the spot of the y-intercept. So there's my slope, there's my y-intercept. Okay, and this one, I want to get the y by itself. I see I've got a 2x squared here and a 2x squared here. Okay, so I'm just going to subtract that off both sides to start, get rid of this and this. So now I have 2y equals 4x minus 7, and then I have to divide both sides by 2. So I have 4x over 2 minus 7 over 2. So y is 2x minus 7 halves, or 3.5. So in the spot of the m, I have 2, so my slope is 2. In the spot of the y-intercept, I have the negative 7 halves. So that would be my y-intercept. For 122, it says Leo solved a system of equations by graphing, and the graph is shown at the right. Estimate the solution from the graph. What is this? Equation for each line, and then solve algebraically. Okay, so this estimate the solution. So it's a little past 1, it's a little above 2 for the y. So it really is just an estimate. I'm going to say I really go with 1.2 and then maybe 2.2. It really is an estimate. I can't really tell from the graph because it's in between. It's not a lattice point. So this is what is the equation for each line in the system. So this line here, I notice has a y-intercept of 1, and then I find another lattice point, like right here. To get from here to here, I go up 1, over 1. So for this line here, it looks like my y-intercept, my b value is 1, and my slope is 1 over 1, or just 1. So my equation would be 1x plus 1. All right, for this one, let's see, the y-intercept seems to be here at 5. And this is going down. I'm going to pick another point to get from here to here. I'm going down 2 and over 1. So my slope is down 2 over 1, or negative 2. So the equation for that line is negative 2x plus 5. All right, so now that I have the system, now I can solve algebraically. So I see they're both set equal to y. So now I would set these equations equal to these expressions equal to each other. So I'd have 1x plus 1 equals negative 2x plus 5. So if I had 2x to both sides, I would have 3x plus 1 is 5. And then if I subtract 1, I have 3x is 4. And then I want to solve for x. So I'm going to divide both sides by 3. So I get x is 4/3, which is the same as 1 1/3. So that's the same as 1.3 repeating, and I estimated 1.2. All right, then I want to get my y value, and I can put that x value in here or here. I think I'm going to pick that first one. I'm going to do 4/3 plus 1. Okay, so I'm going to think of this as 1 over 1. My common denominator would be 3, so this would be 3 over 3. So I would get y equals 7/3. So I get a solution of 4/3, 7/3. So 1 1/3 and 2 1/3. So I was close-ish, but I was off. So that's why graphing isn't always the most accurate. All right, 123, we're given the situation where we want to write a system and then solve a system. So as treasurer of his school's FFA club, Kenny wants to buy gifts for all 18 members. So I know there are 18 members. You can buy t-shirts for $9 and sweatshirts for $15. He has $180 to spend. He wants to spend all of his money. How many of each type can he buy? So right there, when it says how many of each type can he buy, that's your hint about the variables. So your variables are the t-shirts and the sweatshirts, the two things he's buying. So I'm going to let X equal the number of t-shirts. I'm going to let Y equal the number of sweatshirts. Now I'm going to write an equation. I'm going to write two equations. One equation is going to have to do with how many shirts were bought total. And the other thing is going to have to do with money, like the cost of the shirts and how much money he has to spend. So if I know the total of shirts that he is going to buy is 18, and the total is made up of t-shirts and sweatshirts, my first equation would be X plus Y equals 18. So this has to do with like the total quantity. Now I'm going to make another equation that has to do with the total amount of money. So if he has to spend $9 for each t-shirt, it's 9 times however many t-shirts, so 9X, plus 15 for each sweatshirt, so 15 times Y, and it's going to be a total of $180. So those are my two equations, and then I want to solve this system. Because I don't have an equation all set up solve for X or Y, I think I'm going to use elimination, and I'm going to eliminate the X's. So I want to create the zero pair or opposites in front of the X's. So I would like this to be a -9. So what I'm going to do is I'm going to multiply the whole equation by -9. So this would be -9X, this would be -9Y, and then -9 times 18. So -9 times 18, which would be -162. Is that right? Am I multiplying correctly? Yes. All right, then this one I'm going to leave the same. So when I do that, the X's cancel. Here, this is going to -9Y plus 15Y is 6Y. -162 plus 180 is 18. And if I divide both sides by 6, I get that Y is 3. So that means 3 sweatshirts. And if there were 3 sweatshirts and the total is 18, then that means there must have been 15 t-shirts. So 3 sweatshirts, 15 t-shirts. All right, so looking at 124, to simplify each expression to 1 without 0 or negative exponents. So one expression, in part D, write the answer in scientific notation. Okay, we haven't talked about scientific notation, so we're going to do it, but I don't want you to worry about the scientific notation part. Okay, for this one, a negative exponent, remember if you have x to the negative m, n equals 1 over x to the positive m. So this would be 1 over 3 to the positive second, or 1/9. This one I see parentheses, so first I'm going to do power to a power, so I have a to the third times b to the second, and then this would be b to the negative third. And I can combine these when I have the same base. I can add the exponents, so 2 plus -3 would be b to the negative first. It says no negative exponents. So this right here, I can think of as a fraction, and this b to the -1 is the same as 1 over b to the positive first. Or I can just think of it as taking this whole thing, moving it to the bottom, and making it a positive exponent. The a to the third does not have a negative exponent, so it just stays there, right? Only the b comes down. So a to the third over b would be our final answer. Okay, this one, I am dividing. When I divide, I subtract exponents. So on the x's, I could do x to the 2 minus 2, or you might just say, oh, I have the same thing on the top and the bottom, that's just 1. And then I have y to the 3 minus -1. So 2 minus 2 is 0. Anything to the 0 power is 1. 3 minus a -1, that's 3 plus 1. That becomes y to the 4th. So I have y, 1 times y to the 4th, which is just y to the 4th. And another way you could think of this one is, again, x squared over x squared, that's just 1. You could also think of it as taking this negative exponent and moving it to the top and making it a positive exponent, which would change it to y to the 3rd times y to the 1st, which is also y to the 4th. Okay, here, like I said, don't worry about the scientific notation, but if you are interested in knowing how you might do this, this would be a half. You've maybe seen scientific notation in science. And then if I subtract my exponents, 5 minus 7 is -2. But scientific notation, the rule is that this has to be a number between 1 and 10. So I would have to rethink of this and move over my power or my decimal and think of this as 5 times 10 to the -1st and then times 10 to the -2nd. So it's 5 times 10 to the -3rd. We haven't talked about scientific notation, so really don't worry about that one. All right, 125. I'm not sure why this is here. It's accidentally randomly pasted some things. Don't worry about that. It says rewrite each expression as a product and as a sum. Yeah, I don't know what that is. All right, I'm not gonna worry about it. So this first one, I would think of this as x plus 7 times 2x minus 5. So this would be 2x squared, 14x minus 5x, and -35. These are like terms. So I'd have 2x squared plus 9x minus 35. And here, if you want to make a box, you can. Really, you don't need to. You just are going to distribute. So 5x times y. And if you want to make a box, and this would just be 5xy, and this would be minus 35x. So your answer would be 5xy minus 35x. And that's it. Okay, this last one, oh, I don't have enough room right there. The last one, let me just write it down here. I'm going to make 2 by 3. So here I will have 3x minus 7. And then here I would have x squared minus 2x plus 11. So 3x times x squared. So x to the first times x to the second, that would be 3x cubed. 3x times a minus 2x, that would be a -6x squared. 3x times 11 is 33x. And this would be -7x squared. So it'd be a negative times a negative would be 14x, and then -7 times 11 is -77. I do notice that I have like terms here, and I also have like terms here. So when I go to write my final answer, I would say 3x cubed, a -7 and a -6 is a -13x squared. 14 and 33 would be what? 47x, and then minus 77 would be your final answer. Okay, so hopefully that was helpful.